Europe and Africa, two vast continents, two distinct worlds, yet in one specific place, they almost touch. The Strait of Gibraltar is this place. Here, the southern tip of Spain gazes across a narrow stretch of water at the northern coast of Morocco. On a clear day, land is visible from either side. The distance is a mere 14.3 kilometers, or about 9 miles at its narrowest point. This tantalizing closeness has sparked imaginations for centuries. It whispers of connection, of unity, of a physical link between two massive landmasses with intertwined histories and vastly different presents. The idea of a bridge or tunnel seems almost logical, an inevitable step in a globalized world. However, this short distance is deceptive. It masks a chasm far wider than miles can measure. The dream of connecting Europe and Africa here remains just that, a dream. No bridge spans these waters. No tunnel burrows beneath its turbulent surface. The reasons are complex. They are woven into the very fabric of the earth itself. They are etched in the annals of history. They are shaped by the hard realities of engineering, economics, and politics. This is not a simple story of a construction project waiting for funding. It is a tale of formidable natural barriers and equally challenging human-made obstacles. Understanding why these continents remain physically separate requires looking beyond the map's simple depiction of proximity. The allure of connection is powerful. Is a physical link an inevitability postponed, or a grand vision destined to remain unfulfilled? The Strait of Gibraltar is more than just a narrow passage of water. It is a dynamic and complex geographical feature. Its narrowest point, as mentioned, is about 14.3 kilometers. However, the strait widens to about 45 kilometers at its western end, where it meets the vast Atlantic Ocean. This funnel shape plays a crucial role in its characteristics. The water here is not a calm, shallow channel. It is a deep and often turbulent conduit. The depth varies significantly. Near the coasts, it might be relatively shallow, but the central parts of the strait plunge dramatically. The deepest point, located in the Camarino Sill area, reaches approximately 900 meters, nearly a kilometer straight down. This considerable depth presents an immediate and significant challenge to any construction project. Building bridge piers to such depths is an engineering feat of almost unimaginable scale and cost. Even a tunnel would have to contend with the immense water pressure at these depths. The seabed itself is not a smooth, even surface. It is rugged, marked by ridges, troughs, and complex geological formations. This underwater terrain makes anchoring structures or boring tunnels exceptionally difficult. The geological makeup of the seabed, a mix of hard rock and softer sediments, further complicates any potential foundation work. The Strait of Gibraltar is one of the busiest shipping lanes in the world. Thousands of vessels transit through this narrow waterway each year. These include massive container ships, oil tankers, military vessels, and countless smaller craft. Approximately 300 ships pass through the strait every single day. This constant stream of maritime traffic creates a significant logistical challenge for any potential bridge construction. Piers would need to be positioned carefully to avoid obstructing these vital shipping routes. The risk of collision, especially in poor weather conditions or low visibility, would be a constant concern. Any disruption to this traffic flow would have major global economic consequences. A tunnel, while avoiding direct obstruction of shipping lanes on the surface, faces its own set of navigational concerns, albeit indirectly. The construction process itself could temporarily impact shipping. More critically, the integrity of a tunnel beneath such a busy waterway must be absolute. The consequences of a tunnel breach, perhaps due to seismic activity or an accident during maintenance, could be catastrophic. The sheer volume of ships carrying diverse and sometimes hazardous cargoes overhead adds a layer of risk that engineers must meticulously account for in any subsea design. The idea of connecting Europe and Africa at the Strait of Gibraltar is not a modern fancy. It has roots that stretch back through history. Ancient civilizations recognized the strategic importance of this waterway. The Romans, masters of engineering, certainly understood its significance, though their focus was more on maritime control than a fixed link. Later, during the period of Moorish rule in Spain, the cultural and political connections across the strait were strong. While no physical bridge was built, the flow of people, ideas, and goods was constant. The desire for an easier, more permanent crossing has likely been a recurring thought for military leaders, merchants, and rulers throughout the ages. In more recent history, formal proposals began to emerge with the advent of modern engineering capabilities in the 19th and early 20th centuries. Engineers, emboldened by successes like the Suez Canal and early Alpine tunnels, started to sketch out ambitious plans. One of the earliest notable proposals came in the late 19th century. Spanish and French engineers explored the idea of a tunnel. These early concepts, however, were limited by the technology of the time. The engineering challenges involved in creating a fixed link across the Strait of Gibraltar are, to put it mildly, monumental. Let's first consider a bridge. The depth of the strait, reaching up to 900 meters, makes traditional bridge pier construction almost impossible. Building foundations at such depths, in strong currents, and on a geologically complex seabed is beyond current proven technology for a structure of this scale. The longest bridge spans in the world today cross much shallower waters or rely on different geological conditions. A Gibraltar bridge would require piers taller than any skyscraper, subjected to immense lateral forces from currents and potential seismic loads. Even if foundations could somehow be secured, the length of the spans required would be unprecedented. To minimize the number of deep water piers and to accommodate shipping lanes, the bridge would need main spans far exceeding anything built to date. The Akashi Kaikyo Bridge in Japan, one of the world's longest suspension bridges, has a main span of just under 2 kilometers. A Gibraltar crossing might require multiple such spans, or even longer ones, pushing material science and structural engineering to their absolute limits. The forces of wind in the strait, which can be considerable, would also place enormous stress on such a colossal structure. Maintenance of such a bridge would be a perpetual and costly endeavor. A tunnel, therefore, is often considered the more realistic option, though realistic is a relative term here. The primary option studied is a railway tunnel, similar in concept to the Channel Tunnel between the UK and France. However, the Gibraltar Strait presents a tougher challenge. So when we compare a bridge versus a tunnel for the Strait of Gibraltar, well, each option presents its own unique set of formidable technical conundrums. A bridge, as we've discussed, faces the almost insurmountable challenge of deep water foundations and exceptionally long spans. The environmental impact of constructing such massive piers in a sensitive marine ecosystem would also be considerable. Plus, a bridge is exposed to the elements, strong winds, corrosive sea salt spray, and the ever-present risk of ship collisions, despite safety measures. The visual impact of such a colossal structure on the iconic landscape of the strait would also be a significant consideration for many. A tunnel, on the other hand, avoids direct interference with shipping and is less vulnerable to surface weather conditions. However, the subsea challenges are immense. The primary geological issue is the presence of two problematic clay-like formations known as the Bullace and Algeciras Fleisch units, which are essentially chaotic masses of rock and clay. These formations are notoriously difficult to tunnel through. They're prone to swelling, squeezing, and collapsing, making them a tunneler's nightmare. Extensive and costly geological surveys, including deep boreholes, have been conducted over decades to better understand these formations. But uncertainties always remain when dealing with conditions so far beneath the seabed. The proposed tunnel designs typically involve a deep railway tunnel, similar to the Channel Tunnel. This would likely consist of two main running tunnels and a smaller service tunnel. The depth required to bypass the worst of the Fleisch formations and to ensure stability means the tunnel would have steep gradients at either end, posing challenges for train operations. Ventilation and safety systems for such a deep and long subsea tunnel would need to be exceptionally robust. Beyond the formidable geographical and engineering hurdles, the Strait of Gibraltar is a zone of complex geopolitical realities. The primary nations involved are Spain, on the European side, and Morocco, on the African side. While these two countries have a long history of interaction, it has not always been smooth. Issues such as disputed territories like the Spanish enclaves of Ceuta and Melilla on the Moroccan coast, fishing rights, and migration have often strained relations. For a project of such magnitude to proceed, it would require an unprecedented level of sustained political goodwill, cooperation, and trust between Madrid and Rabat. The presence of Gibraltar, a British overseas territory on the southern tip of the Iberian Peninsula, adds another layer of complexity. Spain claims sovereignty over Gibraltar, a claim the UK and Gibraltarians themselves reject. While a fixed link might not directly pass through Gibraltarian territory or waters depending on the chosen route, its strategic implications would undoubtedly involve the UK. Any major infrastructure project altering the strategic balance in the strait would require careful diplomatic navigation involving all three parties. The very waters of the strait are subject to international maritime law, further complicating jurisdiction and control over any potential structure. The military and strategic significance of the strait cannot be overstated. It is a choke point, a critical passage for naval vessels moving between the Atlantic and the Mediterranean. Control or influence over this strait has been a strategic objective for empires and nations for centuries. A fixed link, whether bridge or tunnel, would become a piece of critical infrastructure with immense strategic value. This makes it a potential target in times of conflict and a factor in regional security calculations. The financial cost of constructing a bridge or tunnel across the Strait of Gibraltar would be astronomical. Estimates vary wildly depending on the design and the year of the study, but figures often range from tens of billions to potentially over 100 billion euros. Securing funding for such a mega project is a monumental challenge in itself. It would likely require a combination of public and private investment, with significant contributions from both Spain and Morocco, and potentially international financial institutions or the European Union. Given the economic disparities between Europe and Africa, the financial burden on Morocco would be proportionally much larger. The economic benefits would need to be substantial to justify such an outlay. Proponents point to increased trade, tourism, and economic integration between the continents. A rail link could facilitate the movement of goods more efficiently than sea or air for certain types of cargo. However, critics question whether the projected economic returns would ever match the enormous upfront investment and ongoing maintenance costs. The existing maritime links are well established and relatively cost-effective for bulk transport. The question remains whether the demand for a fixed link is sufficient to make it economically viable, especially considering the alternative of improving existing port and shipping infrastructure. The issue of migration is a highly sensitive one in the region. The Strait of Gibraltar is already a significant route for irregular migration from Africa to Europe. A fixed land link, even if tightly controlled, could be perceived as creating new pressures or vulnerabilities related to migration management. Both Spain and Morocco invest heavily in border security in this area. Despite the colossal challenges, the dream of connecting Europe and Africa via a fixed link across the Strait of Gibraltar endures. For such a project to move from dream to reality, several critical factors would need to align. Firstly, significant advancements in engineering and construction technology would be essential. New tunneling techniques capable of dealing more effectively and economically with the difficult geology, or innovative bridge designs suitable for extreme depths and spans, could change the feasibility calculations. Material science breakthroughs could also play a role in making structures more durable and cost-effective. Secondly, a profound and sustained improvement in political relations and trust between Spain and Morocco is non-negotiable. This would require resolving or setting aside long-standing disputes and committing to a shared vision of long-term cooperation. The active support and involvement of the European Union would also likely be crucial, both politically and financially. A stable geopolitical environment in the wider Mediterranean and North African region would further create a more conducive atmosphere for such a massive, multi-generational undertaking. The project cannot succeed if it is viewed with suspicion or as a strategic liability by key regional or global actors. Economic conditions would also need to be favorable. Both continents, particularly Morocco and Spain, would need to see a clear and compelling economic case for the investment. This might involve projections of significantly increased trade and economic growth that cannot be achieved through existing transport infrastructure. Perhaps a global shift in trade patterns or a new emphasis on intercontinental land transport could bolster the economic arguments. Finding a viable funding model that does not place an unsustainable burden on the involved nations is paramount.